All right, everybody, welcome back. I'm so excited for this deep dive.
Yeah, me too.
We're going to be talking about GNSS,
Uh-huh.
which is Global Navigation Satellite Systems.
That's it.
You know, we all use this technology every single day,
Absolutely.
whether we realize it or not.
Whether you're using your phone to get directions,
Right.
or you're a farmer using it to plant crops, or a pilot navigating a plane, GNSS is everywhere.
And it's so cool.
Yeah, and the applications are just growing.
Every single day.
Expanding rapidly, yeah.
So to break it all down, we have a fantastic expert with us.
Hello.
Hi. So maybe we can just start with like the most basic question.
Sure.
What is GNSS? I mean, we
Right.
said what it stands for, but what is it really?
Okay, so GNSS stands for Global Navigation Satellite System, and it's basically a network of satellites
Okay.
that orbit the Earth and transmit signals that allow us to determine our position anywhere on the planet. It's like a high-tech version of using the stars to navigate.
I like that.
Yeah, so instead of stars, we use these man-made satellites. And these systems, they provide location, information, latitude, longitude, altitude, and even time
Wow.
with incredible accuracy.
And it's not just one system, right?
That's right.
There are multiple ones.
Yeah, there are several GNSS systems operating right now.
Okay.
The most famous one is GPS, which is operated by the United States.
Right. Everyone knows GPS.
But there's also Galileo, which is the European system. Beidou, developed by China, and Glonass, operated by Russia.
So are they all like doing the same thing?
Essentially, yes. They all have their own constellations of satellites
Okay.
and their own ground stations and control systems.
Interesting.
But they all work on the same basic principle of using satellite signals to determine location.
And so like my phone
Yeah.
can use all of them?
Many modern devices can actually use signals from multiple systems at the same time.
Oh, wow.
This is what we call multi-GNSS.
Okay.
And it's really beneficial because it increases the availability and reliability of positioning.
That makes sense because sometimes like if I'm in a city with tall buildings,
Exactly.
sometimes it doesn't quite know where I am.
Yeah, that's a common challenge with GNSS.
Okay.
Buildings and other obstacles can block or interfere with the satellite signals.
So that's like why sometimes it says I'm like in the building next door.
Exactly. Yeah, and that's where having access to multiple GNSS systems can help.
Okay.
Because if one system's signals are blocked, another system might have a clear line of sight.
Okay, that's super interesting.
Yeah.
So how does it actually work? Like how does my phone...
So your phone has a little GNSS receiver inside.
Okay.
And this receiver picks up signals from multiple satellites.
Okay.
And each signal carries information about that satellite's position in space and the exact time the signal was sent. So by measuring the time it takes for that signal to travel from the satellite to your phone, the receiver can calculate the distance between you and that satellite.
Oh, okay. So it's about like the time it takes.
Exactly. It's all about timing.
For the signal to travel.
Yes, and you need signals from at least 4 satellites to get a good 3D position fix.
Right.
Because with 4 satellites, you can imagine you're sort of triangulating your position in space.
So it's like those math problems we had to do in high school.
It's exactly like that. It's
Wow.
like drawing circles on a map.
Ah.
Each circle represents the distance to a satellite
Right.
and where those circles intersect.
That's where you are.
Boom, that's your location.
Wow. Okay. So like, are there ever times when it's not very accurate?
Absolutely.
Right.
GNSS accuracy can be affected by a whole range of factors.
Okay.
Like I mentioned before, obstacles can block or distort signals.
Yeah.
But even things like atmospheric conditions.
Oh, really?
Yeah, the ionosphere and the troposphere can actually delay the satellite signals.
Wow. I did not know that.
Yeah, and that can introduce errors into the position calculation. And then there's something called multipath errors,
Hi.
which is when the satellite signals bounce off of surfaces like buildings or mountains before they reach your receiver.
Okay.
And that can also cause inaccuracies.
So how accurate is it then? Like if I'm just using my phone normally?
So basic GNSS, using your phone or a standard car navigation system,
Right.
can typically get you within a few meters of your actual location.
Okay. So that's why sometimes if I'm trying to find like a specific address,
Yeah.
it might be like a house or two off.
Exactly. But for some applications, that's not nearly accurate enough.
Okay.
Like if you're talking about self-driving cars
Yeah, they need to be really accurate.
or precision agriculture,
Right.
you need much higher accuracy.
Right.
Often down to the centimeter level.
Wow. Centimeters.
Yes, centimeters.
That's amazing.
And that's where techniques like differential GNSS and real-time kinematic or RTK come into play.
Yeah. That's actually the perfect segue.
Yeah.
Because our source material actually talks about RTK and its use in agriculture.
Yeah.
And I got to say, when I first read about this, the idea of a tractor, like driving itself around a field with centimeter-level accuracy.
Incredible.
It just seems wild.
Yeah, and it's not science fiction anymore.
It's real.
It's happening right now.
That's amazing.
So with RTK, you have a base station that's set up at a known location.
Okay.
And it's receiving signals from the GNSS satellites.
Yeah.
And it's comparing its known position to the position calculated from the satellite signals.
Okay.
And it's able to calculate corrections for those signals. And then those corrections are transmitted to a rover.
Which is like the tractor.
Exactly, the tractor or any other vehicle or device that needs precise positioning.
Okay.
And by applying those corrections, the rover can achieve that centimeter-level accuracy.
That is so cool.
Yeah, and there are even network RTK services that provide these corrections over wide areas.
So farmers don't have to set up their own base stations.
Exactly.
That's really convenient.
So they can subscribe to these services and get that high-precision positioning data wherever they need it.
And so how does this all benefit farmers then?
So the benefits of RTK GNSS in agriculture are huge.
Okay.
Farmers can automate tasks like planting, fertilizing, and harvesting with much greater precision.
Yeah.
And that means they can optimize their use of resources.
So less waste.
Exactly, less waste.
Okay.
They can reduce water consumption, minimize fertilizer runoff.
Which is good for the environment.
Yes, very good for the environment.
Okay.
They can even predict optimal harvesting times, leading to higher yields and better quality crops.
So it's not just about saving money, but also about the quality of the food.
Absolutely. It's about sustainability, efficiency, and ultimately producing more food with fewer resources.
That's really amazing.
And, we've come a long way from paper maps to turn-by-turn directions.
It's incredible how fast this technology has advanced.
Right, and it's only going to continue to evolve.
So what do you think is next? Like, where do you see GNSS going in the future?
Ooh. That's a big question.
Yeah.
But, I think we're going to see even more integration of GNSS with other technologies, like artificial intelligence and the Internet of Things.
Yeah, like smart cities and stuff.
Exactly. So imagine personalized traffic management systems.
Okay.
Based on real-time GNSS data from all the vehicles on the road.
Wow.
Or drones delivering packages with pinpoint accuracy.
That would be amazing.
Yeah, or even augmented reality applications that overlay digital information onto the real world.
Like Pokemon Go, but for like everything.
Yeah, something like that.
That's really cool.
The possibilities are really endless.
I'm really excited to see what happens.
Yeah, it's a very exciting field to be in.
Well, thank you so much for sharing your expertise with us today.
It was my pleasure.
It was fascinating to learn about GNSS and all its applications.
Yeah, thanks for having me.
And for everyone listening, we hope you enjoyed this deep dive into the world of GNSS.
Absolutely.
It's a technology that's shaping our world in so many ways.
In ways we probably don't even realize.
Yeah.
And it's only going to become more important in the future.
So stay tuned.
Absolutely. And thanks for listening.
See ya.